Hi guys, it's Miss Riddle, and I'm sorry I'm not with you today in class. I am actually on my way to Kansas to participate in the Walk to Defeat ALS with my family and honor my dad. And so I'm sorry I'm not going to be there, but I did want to make this video so you don't get behind the other class and do a little bit of an exploration with you. So in your notes, you should find this page. We're going to consider two interesting equations. So if you need to pause this, go ahead and pause this until you can find this in your notes. And then when you have them, go ahead and start the recording and we'll just complete this together. So the first thing we're going to do without our calculator is we're going to make a table and a graph for each of these two equations. Now when I'm looking at this, I could rewrite this as y equals, but I think the easier thing to do might be to just pick some simple values for y and figure out what x would equal. So for example, if I make y 0, hold on, that's kind of fat. Let me fix that. If I make y 0, then x would be 0. If I make y 1, then x would be 1. If I make y negative 1, then x would be positive 1. If I make y 2, x would be 4. And if I make y negative 2, and then x would be also 4. And then if I make maybe y 3, then x would be 9. Okay? So there would be a table for our first function. So if you skip ahead and you flip in your note, and I have it on 2 pages, you probably only have it on 1. But let's go ahead and graph that. So that was 0, 0, 1 negative 1, and 1 positive 1. And then it was 4, 2, and 4, negative 2, and our other value won't fit on our graph. But if we connect that, it makes what's called a horizontal parabola. Okay? And then let's put in the domain. Our domain is going to be, looks to me like 0 to infinity, or x is greater than or equal to 0. And our range looks to me like all real numbers, because this is growing this direction, and this is growing in that direction, and we only have one intercept of 0, 0. Okay? So that's our first, we can't call that a function, can we? Because it does not pass the vertical line test, but that's our first equation. So let's go back to this page, and I'm really stumped what to do here. The only thing I can think to do, if I solve for y, that's a big mess. So what I'll probably do is just pick something easy. What if I made x equal to 0? Then y would be 5. If I made x 0, y could also be negative 5. And I could repeat that, and I could make y 0. And if I make y 0, x could be 5. And if I make y 0, x could also be negative 5. Do you see how these make the equations true? If I pick a number 1 in here, I'm going to get a real funky square root. For example, if I picked x as 1, I would get 1 plus y squared equals 25. Y squared equals 24. Y is equal to plus or minus the square root of 24, which that's not a very easy number to deal with, is it? But I'll just use my calculator real quick, and I'm kind of curious. The square root of 24 is 4.89, so we'll do 4.8. And if I made x negative 1, I'd get the same value. Okay, and I could continue doing values, so let's go and graph that. So I've got 0, 5, negative 5, 0, 0, negative 5, and 5, 0. And at 1, it was about, what, 4.8? So it was probably like right here. Okay, and then my other value, negative 1, was 4.8. And this is actually going to make this shape. That's going to make a circle. Whoa. Well, that's a terrible looking circle up there in quadrant 1. Okay, so my domain here is going to be negative 5 to 5 with those values included. My range would be the same. Negative 5 to 5, both included. And my intercepts would be 5, 0, negative 5, 0, 0, 5, and 0, negative 5. Okay? All right, so let's continue thinking about these. How are these relationships different from others you've been working with? Well, these are not functions. Did you notice that? They do not pass the vertical line test. Okay, so let's rewrite these so we could graph them in our calculator. Well, I don't know if you noticed this, but our calculator has a y equals. This is not a function, and we can't graph functions in our calculator. Our calculator won't accept a function. So we have to get a little bit creative here. So if I have x equals y squared, I'm going to square root both sides, and I get y is equal to plus or minus the square root of x. Okay, so remember when you square root a squared variable, you have a plus and a minus option. So in your calculator in y1, graph the square root of x. And in your calculator y2, graph negative square root of x. So take a minute, hit pause, and graph that and see what that looks like. So if you had graphed those, you would have seen that horizontal parabola that we had earlier. Now let's do the same thing here. We have x squared plus y squared equals 25. And I can solve that equation for y. Then I'm going to square root both sides. So y equals plus or minus the square root of 25 minus x squared. So in your calculator in y1, do the square root of 25 minus x squared. And in y2, do negative square root of 25 minus x squared. So go ahead and put those in your calculator and pause so you can get a look at what that looks like on your calculator. One thing I'm going to suggest that you do if you are using either the Inspire or the 84 is to do zoom. So hit the zoom button, and we're going to do zoom square, which on the 84 is a 5. And that will make your window a square, and it will make it proportional. Now, if you haven't noticed, our calculator makes a rectangle shape and it distorts our graph. So go ahead and do zoom square, and I think you'll see an accurate shape of what x squared plus y squared equals 25 looks like. So we're going to skip this part right here because of time, so skip this part in your notes. So let's read this part. A circle has a special characteristic, its radius, which defines its size. Look back to this graph, and what is the radius? And the radius is 5. Do you see a 5 there? So the pattern is x squared plus y squared equals r squared, with r equaling the radius. Now this particular function is centered at the origin, but I bet you can imagine that not all circles are centered at the origin. So let's go back up here. Our pattern for a circle is going to be x minus h squared plus y minus k squared equals r squared. And that k is different. We're used to having a plus k, but we have a minus k here. So hk is the center, and r is your radius. So let's think about this. What would be the equation of a circle that is centered at 5, negative 7 with a radius of 10? So we would use our pattern, x minus 5 squared plus y minus a negative 7, which would just be y plus 7 squared, equals 10 squared, which would be 100. If we wanted a radius of 12, but still centered at 5, negative 7, that would equal 144. Okay? All right. So once again, to summarize, x minus h squared plus y minus k squared equals r squared. R is the radius, hk is equal to the center. with h as your x and k as your y. So real quick, let's take a look at this. How can we find the radius of the circle? Well, we could take the square root of 169. So I'm going to do that real quick. Second, square root 169. I think it's 13, but I'm going to check it, and I'm right. So our radius would be 13. What is the shape of the graph? Well, we know that pattern now, that it's a circle. And then what information can you learn about the graph? We can tell the center, and we can tell the radius. So if we were to sketch this graph right here, it'd be nice if we had some graph paper, but we'll just wing it. So it's going to be centered at 4, -1. So I'm going to go over 1, 2, 3, 4, and down 1. Now it has a radius of 4. So from each point, up and down, I'm going to go out 4. Left and right, I'm going to go out 4. 1, 2, 3, 4. So that point's easy. 1, 2, 3, 4. There's that point. 1, 2, 3, 4. I counted up 4. 1, 2, 3, 4. And I counted down 4. And then I'm going to draw my circle. And there's my circle graphed on an XY coordinate. Radius of 4, center of 4, -1. So that's how we graph circles, and it's pretty straightforward. So once again, this is the pattern that you need to know. And if you have any questions, I'll be happy to help you when I get back, and I hope you have a great 3-day weekend and be safe. Okay, thanks guys. Bye.